Complete. We will solve question D of session 1. For this question, px equals 4x power 5 plus square root of x. We change the square root to x power of 1 over 2. We will complete 4x power of 5 first using power rule, which is nx power of n minus 1. So we apply the rule 5 go down will be 4 times x, 4 times 5 x power of 5 minus 1 will become 20 x power of 4. Now for the x, we also apply the power rule. X 1 over 2 will bring down 1 over 2 times x power of 1 over 2 minus 1. It will become 1 over 2 x power of minus 1 over 2, and for the n we must make it a positive, so we'll bring it down. So 1 over 2 over x 1 power of 1 over 2. And then we change it back to square root 1, and then it will become 1 over 2 over square root of x, and this will be the final answer, 20x power of 4 plus 1 over 2 over square root of x.
Okay, thank you.
Afternoon to lecturer. My name is Dennis Jusip and my video lecturer will be Iman. And we are from station 2 and group 2. Today we will be presenting one of the questions that we picked, which is fx equals 2x cubed times 3x squared. So the question requires us to start by first expand the number, then differentiate it. So to expand the number, we could start by expand ax, which is 2x cubed, and bx, 3x squared, into one big number. The big number will be cx. So when we expand 2x squared and 2x cubed and 3x squared into one big number, it will be turned into 6x to the power of 5. To solve this, since we already expand that number into one big number, we are going to differentiate with a polynomial derivatives by using power rule. So we solve it by take the number from above. For example, the given question is 6x. The answer that we got from expanding is 6x to the power of 5. We'll take the power of 5 times with 6, it will be 30. And then x power of 5 will minus by 1. So when you subtract it, the problem will be written like this. And when you further solve it, the final answer will be 30x to the power of 4. That's it from our station. Thank you.
Okay, good evening to everyone. Good evening to Madam. My name is Mohammad Haffiz from Matlan. Alongside with me is
Shafiz.
And we have done this question for subject 3. So session 3, I mean, where pt is equals to 50t power of 2. So the question asks us to find the p naught t as well as p naught t when t is equals to 3. So to find p naught t, we have to get this equation, the normal one, 50t power of 2. We have to apply the power rule where nx is equal to n minus 1. Nx n minus 1. So since the n is 2, we bring the 2 in front, so 50 times 2 power of t 2 minus 1, and we will be getting 100t. So this is the p naught t. So to find the p naught t when t is equal to 3, so we just apply the t when it is 3. So from this earlier p naught t that we have got, 100t, we just use the t and we substitute it to 3. So 100 times 3, we will be getting 300. So that is all from us. Thank you very much.
Thank you very much.
Good evening for everyone. For the station number 4, our group has done the question about algorithm runtime. So the equation given t n equal 0.001 n power of 3 plus 0.5 n power of 2. So the question given is find rate of growth dt over dn. So now we write the normal equation first. dt over dn equal d over dn 0.001 n power of 3 plus 0.5 n power of 2. So next step, we apply the power of rule, which is dt over dn equals 0.001, and we multiply the number in front and reduce the power by 1. So after we do this, we get the answer dt over dn equals 0.003 n power of 2 plus n.
Very good greeting to the viewers. So today I'm going to explain about the data transfer rate and how we're going to find the acceleration of data transfer. So we are given the equation bt equals to negative 2t squared and plus 40t, and the question asks us to find the acceleration. So since bt, this equation is in the form of bt equals to ut plus vt. This you can see is a function, and this is also a function. So we can use the sum rule, which can define as the b derivative of bt equals to the derivative of ut and derivative of vt. And since vt and ut is simple, so we can use the power rule and constant multiple rule. We can use the constant multiple rule for the ut, and we can use the power rule for the vt. And to find the derivative by using the power rule and constant multiple rule, by using the constant multiple rule for ut, we move the 2 down, and we multiply with the negative 2t, and the power will divide by will subtract by 1. So the derivative of ut will get negative 4t. And for the vt, we're using the power rule. So the power 1 if moved down and is subtract by 1. So the final product for the derivative of vt, we get 40. And finally, we combine it together, we can get the acceleration of data transfer is equals to negative 40 plus 40. Yeah, so this is our explanation about this question.